Hey everyone, welcome back. In the previous episode, we started our TDD solution where we started with just a counter that has a name, and we ended up with a counter class, with a counter manager class, and the whole thing was developed writing tests. In this episode, we're continue writing tests to develop our program. But first of all, what I want to do is rename and refactor some stuff in this test class. So first of all, what I want to do is this has name. Really has no place here. This is like a foot in the door test, as I explained in the previous episode. So what we can do is just delete it. Now the real things that the counter test class is testing is really the counter manager. So that's what we can do. We can rename the counter tests to counter manager tests. So I'm going to press Ctrl R twice and rename counter tests to counter manager tests. I'm going to check that that has renamed the file as well, and it did. I'm happy with that. Now, the counter manager tests, they also test the getStatistics function, which is currently on the counter class. So what I'm going to do is I'm going to take the getStatistics class, I'm going to Ctrl X to cut it, and I'm going to put it on the counter manager. Let's put it somewhere at the top here. Okay, now that is going to break some of our tests. And essentially what I will have to do is pass the counter as a parameter here as well. So now I can grab the count of the counter and grab the percent and return it here. Now we can remove this roundup since now it belongs in this class, and we can actually make it private so we don't actually have any tests for it. And for these broken tests that we have up here, let's go ahead and create a counter manager that we can use. So let's go ahead and create a new counter manager, getStatistics, and let's not forget to pass our default counter here. Okay, I'm going to copy this part here and essentially replace this much, the whole beginning up to the 5, and that should fix the errors. Okay, and up to the total as well here. Okay, let's run the test and make sure that everything still works. Okay, so our tests are still passing. Nice. I will leave the counter manager tests alone now that I know that the counter manager tests are testing just the functionality that is related to the counter manager. The counter is just a byproduct of that. Now, as I've said before, the counter on its own doesn't really amount to much. The counter is part of a bigger system. The whole voting system is made up of counters, right? So we have to make something that essentially holds these counters, right? And usually the place where you can vote is called a voting poll, right? So you go to a voting poll, you go to a booth, and you drop your vote in, right? So that's what I'm going to call this class, a voting poll. This is what I want to develop. So let's go ahead and create voting poll tests. I'm going to go into the Solution Explorer. I'm going to create voting poll tests. Let's start with a fact, nice and easy. Get our X unit in here, delete these not used using statements. Get a public, void. Now with any voting poll, just because I know that it's going to be an object, I know that it should contain counters. What I'm going to do, if you're going to have a collection, another good way to get your foot in the door and actually check for errors, because this is a common error when you're writing code, is that having a collection on a class and it being null. You always want to initiate your collection when you create a class, right? So let's go ahead and test that it has 0 counters when created. Okay, let's create a poll. This is going to be a new voting poll. So it doesn't compile, we stop writing the test and we generate the class. I'm going to make it public and then we can carry on. Here we can assert for not 0 but rather empty poll counters, right? So we're going to check the counters of the poll and check that the collection is empty. Now we can generate this field, or it should be a property really. Let's not do it this way. I'm going to create a prop. I know that it's going to be a IEnumerable or a collection. I'm going to go with IEnumerable first and then see if I will actually need to be adding stuff to it. If not, if I just need to assign to it, IEnumerable will be good, right? And I just know that it's going to be a counter, so I'm going to provide counter. Let's go ahead and bring in our imports, and let's rename this property to counters. This is just a C# thing. You don't need a setter on here. And let's run this tests. Now this is going to fail because this is going to be a null pointer exception. It's going to be a null. Here it is. Argument is null. Now a thing that you can do with enumerables is you can grab the counters and you can grab the enumerable class, not enumerable. Enumerable class, you will need system.link for it, and you can generate an empty. Now the difference between this and the new list counter, so we can initiate it like this, or we can initiate it like new list counter. The difference between these two is that this occupies space on memory, this doesn't. So this is essentially easier on the garbage collection. So when possible, you want to use this. Okay, and I think it's a little bit more readable, but that's beside the point, right? So we initialize it from the constructor, run the tests, and they're passing. Now, we want something to be able to create a voting poll. Now, usually, if you think about it, a user will have some kind of interface where they will need to input some kind of information about the poll before creating it. So from what I'm seeing is you might have a name, you might have a description for the poll, you might not, but the primary things is you want the titles or the names for the counters themselves, for things that you can vote. Okay, and it's not a voting poll if there is less than 2 counters, right? What are you going to vote for just one option? Of course not. You need more than one option to vote for, right? This is just applying domain knowledge, the things that we know about voting counters and stuff like that. You can go on the internet, search for like voting polls if you don't have enough domain knowledge. This is a relatively easy thing, right? Let's go ahead and create a class that's going to be responsible for creating the voting poll. Usually something that creates things, we call it a factory. So let's start off with creating a test suite for VotingPollFactory tests, right? Because the class is going to be a VotingPollFactory because we're going to be creating the voting poll. So let's go ahead and create a class, VotingPollFactory tests. Okay, and by the way, if you're worried about having too much classes in one file, don't worry about this. We will clean this up later. It's just a little bit easier when you're writing tests to not jump between files, but rather scroll in one file. Okay. Another thing we can do here, we can actually move this assert. So using static assert, and we can delete this class here. Let's clear the condition that when we create a voting poll, or rather when the factory is going to create the voting poll, we need at least 2 counters. And when the voting poll is going to get created, the way I see it is we don't need nothing more than the counter name. Okay, so for each counter that we want the voting poll to have, we just need a name. We don't need the counter, we don't need the percentage, because those things don't exist yet. Okay, so let's go ahead and do that. Let's write fact that public void, and we'll have a method that's gonna create the voting poll, and because it's a voting poll factory, the create function will create the voting poll. Okay, so create function will throw if less than 2 counter names. Okay, if we have less than 2 counter names, we're gonna throw an exception. Throws, let's replace if with when. So let's create our factory equals new voting poll factory test. We can remove the tests part. Okay, let's create the class, generate class. Let's make it public. So once we have our factory, we can go ahead and try to call the create function, right? So this is going to be factory.create, and at the moment the function doesn't compile. But one thing about this test is that we're going to be providing counter names, and there's going to be a list of counters. So before I create this function, sort of spare me the time of writing the variables, the parameters there, I'm just going to go ahead and create the names that I'm going to pass there. So this is going to be a new string array, or let's remove the string part. and make it more of an enumerable thing. It's going to be static anyway. So let's say a name. It doesn't matter which one. Let's actually remove the a. So let's pass the names here. Let's create the function. And this is, again, this is going to be public, and this should throw. So let's go ahead and assert, or rather throws, and this is rather a function to which we pass, just like that. And this should throw an argument exception. We can create a custom exception. I will opt in for just an argument exception. So an argument exception is the exception that is thrown when one of the arguments provided to a method is not valid. Okay, so it's not valid to have names that are a count of less than 2. Okay, so let's run this. So it's failing, so let's go ahead and take a look why. It throwed an exception, but a different type exception. We throwed a not implemented exception, so let's go ahead and just throw an argument exception. Okay, we don't need to check for a count or anything, we can just throw because we don't have any other criteria. So now let's say if we'll just copy the test, because obviously if we are checking for an error, there is an opposite condition to that error, and create will essentially create a counter for each provided name. So create returns counter for each provided name. Now I'm expecting the voting poll to contain the counters that the create function will have. So returns counter for each provided name isn't entirely correct. Let's say creates counter for each provided name and adds to poll. Okay, or do we need, the test will infer that. Yeah, creates counter for each provided name. It's not going to return the counters, but it's going to create those counters, and we're going to test that. So we will check name and name 1. So let's do name 1 and name 2. Okay, this is no longer going to throw. This will factory. Oh, sorry, poll. Just like that, right? So this doesn't compile. So the creates, I'm gonna assume that the create function is going to return a voting poll, right? So let's go ahead and make it return a voting poll, just like that. And now we're going to assert that for each of our name, name and names, we're gonna check that essentially each of these names is within the counters in the polls. This is how we're gonna know that these counters have been created for each name. We're gonna use the contains function, name and poll counters, and because these counters are objects, we actually need to go ahead and select the name of the counter, right? So we're going to be checking against the names. Okay, so let's go ahead and run this. Okay, so this fails because this throws argument exception. Of course, we will just be sensible and we'll say that names.length less than 2. We're going to go ahead and throw. Otherwise, let's return a new voting poll, and let's remove these brackets. And counters, we will, for each of our names, we will select a new counter where the name will be X. Okay, and if it makes it any easier, you can rename the X to actually be name. Okay, so this select statement will essentially loop over every name and return a new counter object. So at the moment, this is an enumerable of counter. So let's see what the error here is saying. That we can't actually assign to it. It's read only. So that could have been a mistake. So what I'm going to do is just put the setter back here, and we're going to set it here like this. Okay, let's run the tests. Cool. Now that we throw if we have less than 2 names, create if we have 2 or more. To be honest, for this one, we can go a little bit further. So let's actually do a theory, and we will essentially, because essentially less than 2 means 0 or 1. So we are only testing for 1 here. So what we would like to do is test for 2. So we don't necessarily need a theory actually. We can just make 2 of these, and first provide an array with name, and for the second one it might actually be easier to use the enumerable empty function again, just string, and maybe call to array on this. Maybe no, that's a little bit too verbose. Let's just go new string array and empty. Okay, an empty string array and an array with just one name. Both of them should fail. Okay. One thing I actually don't like is this provided. This is something that is already implied. We're providing these names. We don't need this as part of our test. So creates counter for each name is enough. Another thing I mentioned is that a poll might have a name or a description. So let's go ahead and code that in as well. So let's go ahead and do one for the title. Let's do public void create adds title to the poll. All right, and we can do something similar. Adds counter to the poll for each name. Let's go with that actually. Sounds a little bit more coherent. Adds counter to the poll for each name. Okay, that's actually what we're doing. So create adds title to the poll. Let's go ahead and get a title. Let's create a factory. Let's grab the factory. Let's create the poll. We are going to supply the title to the poll. This is going to break because we don't actually have the names, so let's grab the names here. Okay, this is going to break because we don't actually have a title parameter, so let's go ahead and make that. Okay, so this is going to break some of our other tests, so let's go ahead and fix this. We're just going to pass in an empty string. And if you want, you can test against an empty string for the title and the description. I'm not going to. Let's run this so we make sure everything else is still passing. Okay, nice. So we got the title. We want to make sure that it's on the poll. We want to assert, and remember, we could start writing or adding the title here, but all the tests are passing, and we don't write any more production code again unless we have a failing unit test, right? So not assert, rather equal poll title, and we are comparing it to the title. We will need to create this property. So on the voting poll right here, let's create a prop string title. Okay, let's run this, and this fails. We grab the title, we assign the title, run the tests again, and this passes. Okay, nice. I'm going to do a little bit of refactoring first because we have a little bit of duplication in the names. The title, we obviously pass the empty title here, and the way we create the factory, right? So let's grab the factory first. Let's cut this. Let's make it a global private and put an underscore here. And now for each of these, we can supply this parameter. We can do the same thing here. Whoa. Let's grab the factory, paste it here, remove this. Paste the factory here, remove this. Let's run this. Okay, nice. So still passing. Next, let's grab the names. We will do the same. So private string array names equals new of this. There we go. Now what we can do, delete the names here, pass that as a parameter here, here, and here. Delete these names, run the test, make sure everything still works. Nice. And we can do the same with the title. So let's go ahead and create a private string title equals title. And we can actually use this title as a parameter here as well instead of the empty string. Again, if you want to test for an empty string, go ahead and write that. I'm not going to. I'm just cleaning this up a little bit. Yep, provide the title here, compare the title here, and delete this. Okay, let's run. Nice. So Next thing we can do is we can do the same but for a description. So a poll is most likely to have a description. Like for example, if you have voting options like ketchup, barbecue, or mustard, you don't know what you're voting for. Like, is it your favorite sauce or your favorite sauce on the sandwich or your favorite sauce on spaghetti? You know, like, what's the crack? So ads, and instead of title, we're gonna grab description, and this is just going to be the same. I'm gonna go ahead and description, create this global field here. I'm just gonna pass the name so I can quickly copy and replace the title here, and we can just provide a sample description, and we will just pass it as another parameter here. Now, again, this doesn't compile, so let's go ahead and do string description. Yep, there we go. We break all the other tests, so let's just pass the description here as well, just like that, and here as well, like that. Let's run the tests. Okay, so clicking on this test, obviously we don't set the description, so it's not equal, so let's go ahead and do that, nice and easy. Description. Oh, and by the way, we actually compared to the wrong thing, so let's actually change the test first. Description. Let's generate variable. Oh, wrong button. I'll just copy this, grab the name, paste it here, remove this property. Let's run this again, and again it will fail because we don't set it there. You don't have to necessarily run the tests before writing this. If you know this is failing, you can go ahead and do this. Although sometimes you will see yourself breaking the rules, and then you will see yourself starting to mess up because of that, and then you'll go back to doing the rules again. So it will be a nice little reminder. You can always fall back on the rules if you're finding things hard. So we check the counters. We can check for empty title description. I'm not going to. We check for the names as well, and we pretty much got our little factory here. Now we can actually refactor. One thing with multiple parameters like this in a method is a little bit frowned upon. So what I'm going to do is I'm going to create a request object instead of having 3 different parameters. I'm essentially going to put these parameters on an object. What I'm going to do is I'm going to actually remove this constructor, and then here I'm going to create a public class request, and here I'm going to create properties. First will be string title. I'm going to copy it 3 times. This one, the second one is going to be description, and the third one can be a string array of names. Okay, and what I'm going to do is I'm going to accept this request here. I'm going to grab these properties from here. Okay, so let's go ahead and quickly clean this up. Dot description. Dot names. Okay, now what we'll have to do is essentially put all of these into parameters. Remember that at the top here we actually initialize all of them. So let's go ahead and grab our VotingPollFactory.request type. So private VotingPollFactory.request, and we can just name this underscore request or default request, whichever one you prefer. I don't mind being it just request. I will say new request here, and let's go ahead move all of these properties up here. We can remove most of this stuff. Remove the semicolons and replace these with the property names, and these are names, and I'm writing in Russian. Yeah, give me a sec. Yeah, there we go. Title and description, put commas after them, and move names to the bottom just because it's the same way around here. So title, description, names, title, description, names, right? So now that we have this default request, we can not forget the semicolon here. So this compiles, right? We can grab this request and we can replace these here However, for this test, actually, we'll need to reset the names. We'll come back to this after we fix the other ones because they're a little bit easier. We don't actually need to change the names array, right? We're just checking that the stuff works. Here we will have to check for request.names. Remove this. Same thing here, pass request. Check against the title of the request. Again, pass request. Check against the description of the request. And here what I will do is for the request names, I will supply, or rather override, the parameters here. We can same again, we can just pass the request here, and we can pass the request here. I will just quickly grab this part here, and again assign it to the request before calling the function, just like that. Now let's run all the tests. Cool. So remember, if you have one or two parameters, one is always preferred, two is okay, three you should think about optimizing it, but you can still live with it. Four, you should really consider it, but it's still okay in some places. More than four, you should probably give it a really, really good consideration. But again, there is production code out there that has more than 4 and 5 parameters, etc. But for aesthetics and for your own sanity and other people's readability, etc., try not to go above 3. So I have this VotingPollFactory, we have our voting poll. We'll keep it all in this class here. And what I will move on to is kind of starting to plan for the database. Now, the primary thing I'm thinking of creating is an Interactor service. So to give you an idea, what will happen is we will go into this voting poll tests and we'll grab the factory request, right? So this is something that will serve as a view model to create the voting poll, and the creation will happen here. This is not where the saving of the voting poll to the database will happen. This is just the creation bit, and this is just a factory. However, the request is valid because that's how we create a voting poll. We need something that will essentially accept a request for creating a voting poll, create the voting poll, and save it to the database. Okay, so what we're after is something that's going to utilize the VotingPollFactory and save it to the database. Uncle Bob describes these services as an interactor object in his architecture book, and that's what, since I'm using his examples of TDD, I'm going to call this a voting poll interactor or something like that. So remember, it's going to consume the VotingPollFactory, and whatever it's going to call the create function and save it to the database. Okay, so we'll keep this file open. Actually, what I want to do is let's go ahead and create a voting poll interactor tests. Okay, and in this voting poll interactor test, essentially what I want to do first is test that it's actually going to create a voting poll, right, using this VotingPollFactory. So that's what we're gonna test, right? Let's start with a fact, and again I'm gonna bring in this. Actually, let's just do it here using static assert, and as we always do, I'll leave these statements up there for now. Say public void. Now for the voting poll interactor, we want to test something that is going to, let's say, create a voting poll, right? So create voting poll uses the factory, or rather not the factory, let's specify voting poll factory to create voting poll. Okay, remember that the primary goal of the voting poll interactor is to create the voting poll and save it. Okay, where we save it is not important, either database or file. We're going to put it behind an interface, and that's going to come in a second. Let's create this test first. So we're first going to need a factory, so let's go ahead and make it. Factory equals new voting poll factory. Okay, what else do we need? I guess we will need the interactor. Interactor. Interactor tractor. Generate a new class because it doesn't compile. I'll just rename this to public. I'll leave the constructor there. I made this test to essentially say that the interactor is going to use this factory to create the voting poll, right? That's what this test says. Uses VotingPollFactory to create the voting poll, right? So what I need to do is put this VotingPollFactory inside the VotingPoll interactor, and you would generally do it through the constructor. Okay, so let's go ahead and take this factory, put it inside the VotingPoll interactor, and it's not going to compile because we don't provide this constructor. So let's go ahead and inject this factory like that, and we will initialize a field. Actually, we don't need to initialize a field yet. Let's try not to break all of the rules. So once we have this interactor, what we want to do is call this create a voting poll function. Okay, so interactor create voting poll. And if we actually want to use the VotingPollFactory to create a voting poll, we'll need a request from the VotingPollFactory class. Okay, but let's go ahead and create this method first. Let's generate the method. It's going to be public. If I wanted to return the voting poll that it creates, I can create a test for it, but not yet. So what we want to do is we want to request. So var request equals new VotingPollFactory dot request. Okay, it doesn't matter too much. We're not going to fill it out just yet. We just want to pass it here, and it doesn't compile because we are not passing the parameters here. Okay, we'll put the request. So how do we test that this interactor is indeed going to call factory with this request? Okay, how do we assert something like this? Well, if you watched the factory, or not the factory, if you watched the mock queue and the XUnit tutorial, you would essentially know this is the time to use mock queue. This is what it's made for, okay? And one thing with mock queue is you always want to use an interface with it, okay? So let's do the bad way first, okay? So let's create a mock library equals new mock. We're going to bring in mock queue for this. Let's create a VotingPollFactory. Okay, and here we would like to check that mock library, verify that here we did indeed call create with this request object. Okay, and that's what we're going to verify. And we will actually need to grab this mock library and pass the object here. Okay, and this factory here, we don't really need it anymore, so we can delete it. Let's go ahead and run this. Okay, so it doesn't pass because the function here is not implemented. So let's go ahead and implement this. What we'll need to do is grab this factory. Let's go ahead and initialize it, and let's grab it and call create with this request. Okay. Okay, and we're getting a null reference exception, and again, this is because we're not using mock library entirely correctly. We are passing in an object instead of an interface. So this is when we actually want to go ahead and create an interface, so we can indeed have this check that the create function has been called with this request. Okay, so let's go back to the voting poll tests. And this is just purely for convenience purposes. Again, we're going to move everything to their separate files later. We'll go ahead and create a public interface. And I'm going to create an iVoting factory. And here what I will do is I'll just grab this much of this function. So the type that the function name will return and the parameters. And put this here. And because it's on the interface, kind of we are exposing, it's kind of declaring what we're going to expose. So it is inferred that this is going to be public. One thing we'll need to do is change this type here. So let's take the iVotingPollFactory, and instead of providing the VotingPollFactory here, let's provide the interface instead. And here too. So now that we're using an iVotingPollFactory, let's go ahead and run this again. and everything's passing. So remember, this is just a big lesson in terms of using mock queue. Do not use it against classes or static classes, static functions. Always use it against an interface. If you're finding that your code is hard to test without putting it behind an interface, the practice of TDD states that code that is hard to test is badly written code. Okay, so then you should go ahead and write it so it's easier to test. That makes it good code because you can then know that it works. So now we know that it requests the creation of the voting poll through this factory. Whatever the factory is going to create, we now want to save it to a database. And we are going to hide the database behind a interface, just the same way that we're going to hide this factory. Okay, so let's go ahead and create a public interface, and I'm going to call it VotingPoll persistence. Okay, and the reason for saying persistence is if I say something like a repository or a database, it kind of ties it to the meaning of the word that you're going to call it. The reason for choosing persistence is we might implement a file system, we're not going to. We might implement a database, we will. But basically saying persistent means we might choose either. This is about persisting what we give to the interface in the long term. We will be able to request this data later on. And this is what I'm going to do. So let's go ahead and basically try to create this interface as part of the test. Okay, because writing code like this is not TDD, right? So let's go ahead and create a fact. Public void create voting poll persists created poll to doesn't matter what to, it just matters that it persists it. Okay, now what we'll need is, let's just grab this much of the test because we will need to pass this, and what we'll need to do is create the persistence layer, right? So let's create a mock persistence, and let's create a I. And do I actually want to call it a voting poll persistence? Let's call it voting system persistence. Okay, so it's just going to be one big repository, okay, for everything. We're going to call everything from here, and if it gets too big, we can split it out. Okay, so mock persistence, let's go ahead and pass this to our interactor as an object. Obviously, we don't have this parameter, so we will have to add this. Say persistence, this will make it pass. We will need to add one here as well, so let's go ahead and add this here. Sure, we fix this test. And let's pass the object. Okay, let's make sure that the test still runs. And looks like there is a less accessible. Oh, internal. Okay, so this needs to be public. Okay, let's go ahead and run this. So everything's passing. Now what we want to do is essentially test that the create function of the factory, where is it? Mock library? Why is it a mock library? Factory. Okay, and we're going to rename it here as well, mock factory. And minor technical issues. Okay, so the mock factory is going to create us a voting poll, and we want to make sure that the persistent layer is going to save that voting poll. So now what we want to do is configure the create function to consume whichever request we pass and to return a special voting poll. So let's go ahead and do that setup. Let's grab our mock factory and let's do a setup where we are going to call create with a request, and this should return a poll. Okay, and this voting poll equals a new voting poll. There we go. Now the variables don't mean too much, even if everything is the same. All we care is that the reference of the object that returns from here is what's going to go inside the function of the voting system persistence. Okay, which will be something like save voting poll. Okay, so let's go ahead and do that. Let's grab our mock persistence, and let's say that verify x equals save voting poll, and this doesn't compile, so let's go ahead and generate a method. Doesn't matter too much what it does just yet. And now we're going to make it pass a poll to it, and make sure that we have this parameter here. And say voting poll, and put a semicolon. Okay, so that's all we're gonna verify. Let's go ahead and run this. Okay, so this is failing. Obviously, we're not passing anything. There are no invocations of this. Definitely not with this poll that this function is gonna return with this request. So this is what we want to do. Let's grab our interactor. Oh, and we didn't even call the create voting poll function, right? So we want to pass the request, and inside our interactor, inside the create voting poll, what we want to do here is once we call create, we want to grab the poll that we create, and we want to grab our persistence layer. So we will have to initialize it. We'll grab the persistence layer, and we'll call save voting poll, and we'll save the poll. All right, simple enough. Oh, let's run the tests, and everything's passing. So this is essentially the baby steps you take towards writing unit tests that essentially depend on a database. What you do is you use a mocking library like mockq to mock against an interface that is going, then the database layer is then going to implement. Okay, and as we go further into the TDD of how to basically implement the database, at one point we'll have a project for the database which will implement this interface. And once we build the actual ASP.NET Core application, you'll see how it all ties together. Okay, but to finish up this episode, let's go ahead and clean this up a little bit. Same as before, we'll just take a look at what is repeating and what we can store away. Okay, so first of all, the voting poll interactor, we're initializing it with these objects, but also we kind of want to verify on them or set them up. Okay, so first of all, these three are identical, so let's go ahead and move them up. I'm going to create a variable for each of them, and they're going to be private request equals new. Boop, one of these. And again, variables don't really matter with that. Remove the one request here. Replace the requests. Make sure tests run. Now let's take the mock factory. And now that we're a little bit more confident that this sort of refactoring doesn't break it, we can go for both of the mocks. Okay, factory equals new. There we go. Let's copy this, put the mock persistence here, and replace the type with voting system persistence. Just like that. Remove these two. Supply these here. Okay, and for the mock factory, we'll use this here. Again, remove these two. Mock factory, and mock persistence. Well, I'll just grab it from this corner here and replace these two. Okay. Now, for the initialization of the interactor, we can still bring this out. So let's create a private VotingPoll interactor, and let's say interactor. We will not initialize it here. What we will do is we will create a constructor. So I used the CTOR snippet in case you're wondering, and press tab twice to create a public voting poll interactor test. So if you want to write the constructor out yourself, it will essentially be the same as the name of the class, okay, but used like a function inside this class. Okay, and what I'll do is I'll grab the interactor and assign this new voting poll interactor class with these parameters of mock factory and mock persistence. Okay, and now we can remove this initialization here and provide our underscore interactor. And same thing here. Let's remove this much, and again kind of making sure that we have the arrange, act, assert set up in our tests, right? So we follow conventions. Okay, so the tests are quite cleaned up. Let's run them, make sure everything still works, and it does. Okay, so the test looks neat, the code looks neat. I think this will be a good end on the episode. Thanks for watching. If you enjoyed it, leave a like, subscribe. If you have any questions, make sure to leave them in the comments. Don't forget to join the description. Don't forget to join the Discord server. And as always, I'll see you in the next episode.